Welcome to the deep dive. Today, we're digging into how businesses try to look ahead, make those big financial calls.
Yeah, we've got a bunch of techniques they use from sort of basic what ifs to more, well, involved stats.
And our mission is to break these down for you, show how companies actually plan and anticipate.
Exactly. And honestly, getting a grip on these concepts, it really gives you a powerful lens for like analyzing business news, company performance, maybe even your own budget.
Okay, let's jump right in. How do companies forecast? First up, sensitivity analysis, the what if scenario.
Right? It's basically tweaking one number, one assumption, and seeing what ripples it causes.
Simple but powerful.
Oh, definitely. Take Besser Company. They projected $100,000 in sales. But if they were off by just 25% high or low,
What happened?
well, their operating income could swim wildly from like $5,000 all the way up to $25,000.
Wow, just from that one sales number being off.
Exactly. It just highlights how critical getting that sales forecast right really is, or at least understanding the potential range.
Okay, so that leads nicely into scenario analysis, right? Looking at multiple futures.
Precisely. Instead of just one what if, you map out a few different outcomes. Maybe things go great, maybe not so great, maybe just average.
Optimistic, pessimistic, most likely.
Yeah, those are the usual ones. Rich Company did this. They looked at growth, decline, or staying flat, and crucially, assigned a probability, a chance to each one.
And that helps them calculate an expected outcome, kind of weighting the possibilities.
Spot on. It gives a more nuanced picture than just one single guess.
All right, let's switch gears a bit. Regression analysis. Sounds a bit heavier.
It can seem that way, but the basic idea is looking for relationships. How does one thing affect another? We'll stick with simple linear regression.
One relationship at a time.
Right. Think y plus bx. Y is what you want to predict, maybe total costs. X is your activity level, like units produced.
An A and B.
A is your baseline, your fixed cost, the stuff you pay no matter what. B is the variable cost, how much extra it costs for each additional unit. Each X,
So you can estimate total costs if you know how much you're going to make.
that's the goal. But you need to know if that relationship is actually, strong.
Ah, okay. So how do you measure that strength?
That's where the coefficient of correlation, RCOF, comes in.
Yeah.
It runs from n=1 to +1.
Positive means they move together, like costs and production.
Usually, yeah, more production generally means higher costs, so you'd expect R to be positive, somewhere between 0 and 1. Negative means they move opposite.
And zero means no real connection.
No linear connection, anyway. Then there's R squared, the coefficient of determination.
R squared. What does that tell us?
It tells you how much of the change in your total costs, say, is explained by the change in X, your production volume.
Okay.
So Raxon Inc. had an R squared of 0.81. That means 81% of the variation in their total costs was pretty much down to how much they produced. That's a strong relationship.
Got it. That makes sense. Okay, moving to something maybe simpler. The high-low method.
Yeah, this one's quite a bit more straightforward, less math heavy anyway.
How does it work? Just look at the extremes.
Pretty much, you find the period with the highest activity and its cost, and the period with the lowest activity and its cost. Ignore any weird outliers, though.
Okay, high and low points. Then what?
You calculate the change in cost between those 2 points and the change in activity volume. Divide the cost change by the volume change.
And that gives you...
Your variable cost per unit, roughly. Then you can use either the high or low points data to figure out the fixed costs.
So you end up with a formula like total costs, fixed costs plus variable cost per units.
Exactly. Like that example. Total cost equals $5,700 plus $2.75x number of units. A quick way to estimate.
Cool. Now what about the learning curve? This is about people getting better at tasks, right?
Right. As workers do something over and over, they get faster, more efficient. The time per unit goes down.
That must affect cost projections, especially for labor.
Hugely. Especially for tasks that are repetitive, labor-intensive, and where people stick around long enough to actually, learn.
So how's it calculated? Something about doubling production.
Yeah, the theory is that each time your cumulative production doubles, the average time per unit falls by a consistent percentage the learning curve rate.
Ah, the average time.
Yes. So if the first unit takes 50 hours and you have a 70% learning curve, when you've made 2 units, the average time drops to 70% of 50, or 35 hours each.
And then at 4 units, the average drops again to 70% of 35 hours.
You got it. It shows those efficiency gains stacking up. Jones Production Company's example showed this really clearly.
Okay, that's fascinating. Let's move to CVP analysis, cost volume profit.
Ah, yes, CVP. This is fundamental. It's all about how changes in costs and sales volume impact your profit.
And the big concept here is the break-even point, isn't it?
That's the star, yeah. The point where you're not making money, but you're not losing it either. Total revenue equals total costs.
There are some key assumptions for CVP, though, right? Like costs being clearly fixed or variable.
Absolutely. CVP assumes costs behave predictably, that volume is the main driver, things move in straight lines. It uses the contribution approach.
Contribution margin, that's sales minus variable costs.
Right. It's what's left over to cover your fixed costs and then hopefully generate profit. It's different from the absorption costing you see in external reports, mainly in how fixed factory overhead is treated.
Okay, so how do you find that break-even point? In units.
Simple formula. Total fixed cost divided by the contribution margin per unit.
So for Greengrass Industries, with 150K fixed costs and a $75 contribution margin per unit, they needed to sell 2,000 units.
Exactly. 2,000 units just to cover all their costs.
And you can calculate it in sales dollars, too.
Yep. Either take those 2,000 units times the selling price or divide the total fixed costs by the contribution margin ratio. Both methods got Greengrass to $250,000 in sales needed to break even.
What if you want to make a profit, not just break even?
Easy adjustment. You just add your target pre-tax profit to the fixed costs in the numerator of that break-even formula. Treat the profit goal like another fixed cost you need to cover.
Makes sense. And finally, target costing. This sounds like working backward.
It is, absolutely. You start with the market. What price can you actually sell this product for? Then you subtract the profit margin you need to make.
And whatever is left, that's your target cost, the maximum you can spend to make it.
That's it. It really forces companies to be lean, maybe redesign products, find efficiencies, sometimes using methods like Kaizen, continuous improvement.
So quite a toolbox we've covered. Sensitivity, scenarios, regression, high-low, learning curves, CVP, break-even, target costing.
Yeah, quite a range. And these aren't just textbook ideas. They're genuinely what businesses use day in, day out to navigate, plan, and try to control their future.
Understanding these really does give you, the listener, a much clearer view of why companies make the decisions they do.
Definitely. So here's something to think about. How do all these different techniques predicting the future, controlling costs, actually interact within a single company's strategy? What do you think are the biggest assumptions, the biggest unknowns that businesses wrestle with when they use these tools?